But yeah, that's fine. You can play around with that, get you where you want it to be. But for me, that seems fine. And now we want to add. What do we want to add? Let's add a goal to get to. So I'm going to create a new object, and we'll go create. And I'm going to create a cube. That's the material we forgot to create, by the way. We didn't create a goal material. I'm going to call this goal. And this is going to be a trigger. Now, a trigger, what that will do is we can still read collision information. It's a bit more limited, though, in the information you retrieve. And you don't collide with it. You just enter it, or you touch it, and it sends a message that we can read. So you don't physically run into it. You can pass through it and still receive the collision information. All that seems fine to me. I want to bring this to the 0, 0, 0, and actually 0.25. And there is our goal. Now I want to create a new material. Call this the goal material. And I want this to be transparent. You may have noticed that last time. This is a transparent material. So I'm going to go transparent under the shaders and go to diffuse. Diffuse. And I am going to make this one green. A pretty green color. Did not make it transparent though. So I want to lower this alpha down a bit. Or a lot. Attach it to that object. Now you can see through it a bit. May change that later on, but we'll see. Now the thing about this game is the way it's set up, it is required to all be kind of perfectly placed. So they have to be on single units. Like I can't have this 4.1192094, whatever that says. I can't have that. I want it to be on maybe 4 and 2. And that's where that has to be, because the walls around it have to be even so that they can fit 1 cube, 2 cube, 3 cube, no more, no less than what is required. I mean, it could be a bit, just a bit loose and not worry about it, but I like the tight look of it. So we have that now. Now what I want to do is, this actual goal has nothing attached to it. There's no class, anything that gets attached to it. We detect the collisions from the player, so when we run into that goal, we'll detect that trigger event and then say, hey, he completed the level, send him to the next level, add his score up. Maybe we'll add coins or some kind of tokens you have to collect first before you can go through that gate. And when you do that, there's a timer and you have to do it before the time's up. Whatever, you know. But for now, we'll have this, run into that, and beat the level. Now let's do our enemy. Now this is where it gets kind of interesting. The player was kind of boring. The goal had absolutely nothing to it. But the enemy, it's pretty cool. So let's go create a new cube. We're just working with cubes today. I'm going to call this enemy. Now I'm going to, with this enemy, I'm going to do something called creating a prefab. A prefab stands for a prefabricated object. That's all it is. It's something that you have built. You have attached components to it, and you want to save that as an object you can just throw out here later. So I can drag this enemy and the components that are attached to it into my objects folder. I'm going to create a new folder inside of objects folder called prefabs. Now inside of this prefabs folder, I will store my prefabs. So I want to create a prefab enemy. I want to drag the enemy into this folder. Now what that has done is it has created an instance of enemy in my prefabs folder. Now I can grab enemy and drag him out into the world, and he will have the components that enemy has. That's the point of a prefab, to contain the same information as the object you created, and then just create instances of that object. Pretty cool, I know. So now let's grab our enemy. 0.25, 0, 0. Drag him here for now. We'll just put him somewhere. And we want to create an enemy class. We want to create a new C# script. Call it enemy. No, we'll do a patrol. I'll attach this to the enemy and make sure it gets on there just like that. Open this up. Now what we have to do in here is we have to create an array, and this array will store all of the transform positions of the patrol points. So the idea with this, at least for now, is that I want to create points in the world that this enemy will walk to. Each enemy will have their own points. They can share points as long as you get the walk timing right. They're based on their own speed, so you can modify that to work. But the point is I want to be able to create, let's do a create empty. Now this will just create a transform, because all game objects in Unity have to have a transform, which is just a point in space that contains rotation and scale information. If it doesn't have that, it doesn't exist. So this is just an empty game object. All it is that single point in space. Now I want to use this information to set up patrol points for our enemy. So I want to zero this out, as I do. Place it somewhere on this world here. And I want to call this patrol point. Now I will create, no, we don't need to, no, for now we'll just leave it a normal object. So now I want to be able to assign this point, and say this point, to the enemy object. That way he can find these points in space and then walk to them. So how do we do that? That's a good question. So I'm going to go to the enemy, and we created that class. I'm going to open that class up. Just a patrol class. The first thing I want to create is a public transform that is going to be an array. Now, we went over arrays in the introduction series, so if you skipped out on that and you don't know what this actually is that we're doing here, I don't really have the time to explain it again, so I will link a video right here on the screen. Click on that and watch the array part of the series. So it's going to be a transform array, and then I'm going to call this patrol points. So now if I would say Control S, come back into Unity, go to the enemy, we will see down here patrol points, and I'll have a size. This one will walk between 2 points, and then I can just take patrol point A and patrol point B and assign them to that. Now it has the point in space A and the point in space B, also the scale and rotation information if you need that. So to start out with this guy is I want to set this object's transform dot position, which is the transform component. Again, we don't need a reference to that in Unity. We don't need a reference to the transform information, as it is available to all game objects. Then I want to grab the position information, which is the position right here, the X, the Y, and the Z for the position. And I want to set that to equal, now watch this, pretty cool, patrol points 0 dot position. So what this is saying is when I start out, I want this enemy's position to equal the position of the empty game object at the 0 spot in this array. So when we start, let me just show you. If I click play, make sure there's no errors. If I click play, he will pop over to the first position, or the first transform position, which you can see is this object right here, and then there is the enemy. Notice he is in the ground. The reason he's in the ground is these patrol points are not 0.25 above the world. Just like that. If I hit play, now he'll be spawned in that area, but on the floor. That's pretty cool. Now, all I have to do is get him to walk to the next one and then walk back to the first one. So the next one would be 1 and the first one would be 0. I could have one for 2, I could have one for 3, and assign those and have 4 positions in the world that he'll walk to. And that would be fine, that would work. But for now, we're going to just work with 2. So 0 is his starting point. And then I want to do an update. In the update, what we want to do is say if, no, first of all, before we do that, I'll have to set up another variable. This one is going to be private current point. Now, I got to set up this as an integer. So what this is going to be is the current point we're on. It's going to refer to the array index. So when we start out, current point will be 0, and then we'll up current point by 1 each time we reach a different point. So say I reach point 1, I want to make current point equal 0 again. When we reach current point, or reach point 0, current point will equal 1. And that'll make sense here in a second, I hope. So I want to say if, I want to set current point to equal 0 when we start out. So you start at the current point of 0. The point refers to patrol point. Current means now, the one it is currently. And it's going to be 0 because we start out at 0. So I'm going to say if transform.position is equal to, remember this operator, instead of, when we want to do this operator instead of the single, and single means you're assigning a value, this means you want to get like a boolean out of it. So if transform.position is equal to patrol points current point dot position. So what I'm saying here now is if this enemy's position is equal to the current point position, we want to do something. So what I actually am saying, without reading that just like it says, is I want to know when I reach the target. The target is the current point. So current point means the current point I'm currently walking towards. So I want to check to see when I reach that position. And when I reach that position, I want to walk to the next position. So the way I check that is I see what patrol point should I be walking to. And the way I grab that is current point will be set to 0 to start out. So what I'm saying here from the beginning is patrol point 0. So where I started. So I'm going to check, say, is my position equal to the patrol point 0 position? If so, I want to do current point plus plus. Now current point plus plus. Plus plus is another operator we've not covered. Plus plus just adds 1 to the current value of current point. So if that was a 1, now it's a 2. If it was a 2, now it's a 3. If it was a 3, now it's a 4. Okay, you get that. So it'd be the same as saying current point is equal to current point plus 1. It's also the same as saying, if I was to say current point plus equals 1. It's the same as saying that. Plus equals, you take the value and add 1 to it and then set the value to equal the value again. So instead of all that, I just say current point plus plus. So now this was 0 on the first pass through, and now it's going to equal 1. So next time it checks this will say patrol point 1 dot position. So it's going to be checking, hey, is my position equal to the control point 1, which is the other area, the other spot in the world I'm supposed to be walking to. And if it isn't, it'll keep walking towards that. It won't yet, but it will in a second when we write the part to do that. And when it reaches that position, it'll up the current point again and then go to the next position. So now what I want to do is set up this system that will actually walk the character. And then we have to check to see if we are at the last point. And if we are, go back to point 0 and start over again. So what I'm going to say is transform dot position is equal to, now we're going to set, now position is a vector 3. So I want to set the vector 3 equal to a new vector 3. But this vector 3 is going to be moving along. It's not going to be a stationary position. It's going to be a position from point A to point B. And then I want to move it along that path. And the way we do that is I'm going to say vector 3.move towards. So it's going to take our current position and move it towards a new position. And each time this is going to be returning a vector 3, so it knows that my position has become a new position. So say it moves 1 unit on the X. When it does that frame, this will be updated to equal that, and we'll base it on time instead of frames so that we don't have any issues with frame rate. say the frame rate 600 FPS again, you know, then you're moving really fast compared to a 60 frame rate. So we're going to base it on time and not frame rate. So move towards. Notice our arguments are current. So current would be the current transform dot position. The target will be the target position, which would be the patrol points, and it would be the current point. So the current point that we're going towards. Why is that not auto completing for me? Is that incorrect? I don't know. Dot transform, or sorry, dot position. And then it wants the max distance delta. Now this is where we're going to modify our speed value and multiply it by the time value. So each of these enemies will have its own speed. So I'm going to set up a public float or integer. No, we'll do float. Float of move speed. Now I will take move speed. I don't know why I'm not getting autocomplete here. Not that I need it in this situation, but it's weird. So I take move speed. I want to multiply it by time dot delta time. Now time is the time class. It's a class that contains a lot of time information. You can timestamp your work, so you can have information based over time, or you can also get the length of the last frame, which is what we're going to be using. So we want to get the time it actually took for a frame instead of the rate of the frame showing. And that way we can understand the frame rate in seconds. Instead of saying, oh, this happened over 60 frames, we can say this happened over 2 seconds. So I want to multiply this by time dot delta time. So it's going to take the move speed and ease it out over multiplying it by dot delta time. We'll take it, and since we're in the update function, it would normally do it every single frame, and then it would be based on frame rate, but now we're basing it on time. So multiplying it by time dot delta time. If I hit Control S, we come in here, and now we have the size we want to set to 2. I don't know why I did that. I already had this attached, didn't I? What am I doing? All I have to do is assign a speed value, say 10, and click play. Now notice he spawned at his 0 position and moved quickly to the next transform. Let's slow that down so we can see that. A tenth of the speed would be good. And he moves to the next position, which is what we want. Now, since he is at the last position, he won't continue on. But say I add another transform, another position in this world. I'll add one way over here. I'll go back to the enemy, grab this, set this to 3, grab that, and place that as the third one. Click play. Now he'll move to that one. When he reaches that one, he will move to the next one. He'll move to that one I put out here. And that's how that works. But now when he reaches this position, we want him to go back and start the loop over. Start at 0 and go from there and continue on. And to do that over and over and over forever. And I have an error. How did I define that? Control. Oh, because I'm adding 1 to the current point when I reach this position instead of resetting it to equal 0. So what I want to do is I want to check before we get to that position, that part of the update. I'm going to say if current point is, we'll do greater than. I believe greater than is what we're looking for here. If current point is greater than patrol points, patrol points dot length, which would get us the number of positions or spaces in this array. So you have an array that is 2 that holds 2 objects. You then have an array with 1 length because of 0 and 1. You have one that holds 5 objects. You have an array that has 4 length, 0 to 4. So we want to check to make sure current point is, if it's greater than the amount of points we actually have, we want to set current point to equal 0. Start over. Go back to the beginning. Clear that. I should no longer get that error. And he should move. That's a long way to go, though. Let's speed him up. Notice how that happened in real time there. Pretty cool. So just because it hits that before it hits that, and then it's throwing me out of range exception. Yeah, that's all it was. Alright, so that's all that was. Now we'll loop over forever, continuously doing that, which is what we want, because a player could take 15 hours to do a single level, and our enemies will never tire out. They will always continue on. So this is a very basic waypoint patrolling system. When you hear somebody talking about a waypoint system, this is what it is. Now, you may see some that look like they're crazy, but this brings it down to just all it really needs to be if you have just a simple waypoint system. Walk to A, to B, to C. Now, in our case, we don't have to rotate our cubes, because if we did, we would cause some issues with our hallways and stuff, because they are just 1 unit by 1 unit. So we can't rotate or anything, or that would cause some issues. But you could do that if you wanted to and rotate towards the direction you're walking. May go over that as well, even if we can't use it. But that's our enemy. Now, what if we run into our enemy? Our enemy's walking, but he is walking, ignoring collisions. He doesn't actually collide with things, as he's just moving with his transform position not being updated. So, me running into him, he'll just, he don't care. And that's what should be happening. He's not smart. There's no AI here. He's just a simple cube, just going about his day, walking from point A to point B to point C, back to point A. That's how that works. But when I run into him, I want to die. And we'll get into that next time. Whew, this was a long one. Thank you for watching. My name is Austin. And in the next part, we're going to cover killing the player. And then we'll get into... what is left? What is left? We have to create a level. We have to do a simple GUI. We might do like a level select screen or something if you guys are interested in that. A level select, kind of like a platformer level select, like a Mario or something. Not like I say Mario, you're gonna get your hopes up for like a world map thing. No, not really like that. We could do that. Or should we save that for our platformer, or should we do it for both? I'll leave that up to you guys. Decide that. Do you want to see the overworld level select system? If so, that's fine. Let me know if there's enough want for something like that. We will add it into this game. If not, we'll do the simple menu select system. But we have to do that. We have to design a couple of levels, and then we have to set up a scoring system. Maybe we'll do some coins in the map you have to get to without dying, and then get out of the world. We might do like a couple different kind of traps. Maybe add some, I don't know, spikes. You know, what game doesn't have spikes? We need spikes. And then we'll have a game. So play around with this, guys. It's super simple. You can take what we've done so far and build onto it and make something fun. If you take the game that we're going to be creating, there's a few more parts to come of this game. But if you take the game we're going to be creating and you make something out of it, I highly encourage that. I mean, this could be really, it could be a good mobile game. I feel like the system is good for a mobile game, where you would control it based on the accelerometer. Tilt controls could be really good for a game like this, and it may not be like a successful game, but it'd be really fun, I think. So if anybody does that, please let me know. I want to play that. That'd be fun. It has to be on Android though, because I'm an Android guy. Anyway, that's it for this part. Thank you for watching. The audio in this one may not have been as good. I may have been off to the side. That's what happens in these long videos. I forget what I'm supposed to be speaking. I just start talking. And I'm also in a new office, so I've been moving recently, which it's surprising I got this video recorded and up. As you noticed, I don't have internet right now. the internet guy, Mr. Xfinity, I think his name is, will be here on Wednesday. So that's kind of stinks. But I'm going to be bumming my friend's internet to get this video up to you guys. Maybe the next one too. But this one's super long, just in case I can only get one up. So maybe it'll make up for that. Anyway, that's it for me. Thank you guys for watching. My name is Austin, and I will see you next time.